Hi, my name is Muhammad Syahmi Shazwan bin Shuhairam, and our group will be presenting about the Gator Smart House SCI evaluation. First, I would like to begin with the introduction of the system background. The Gator Smart House is a second-generation programmable smart home developed by the University of Florida, and the core objective of this system is it is designed specifically to help the elderly and disabled individual who live independently at home. The system operates on a ubiquitous computing model where technology is deeply embedded and context-aware and invisible. And the target user of this system is elderly resident with reduced mobility, disabled resident, and remote caregiver monitoring health status of their patient. Next, I would like to show you the improved version of the system architecture diagram. Okay, this here is the older version of the system architecture diagram of the Gator Smart House. And another one is this one, which is the improvement of the system architecture diagram of Gator Smart House, where we propose three new component, three new layer, where it is the first one is the adaptive notification manager, and the second one is the privacy and access control engine, and the third one is the privacy and calm dashboard. And next is I would like to continue with the ESI problem identified in this project, in this system. And the first one is the lack of transparency, where the system score meets in transparency. While the operation is invisible, there is zero data transparency, and the home has no resident facing privacy dashboard to monitor what is being collected. This means that the resident itself don't know what data is being collected on their activity in the home. And the second one is the surveillance anxiety. Because sensors are completely invisible and data sharing is hidden, elderly residents experience psychological stress, feeling watched rather than assisted. And the third one is the static attention delivery. The system itself lacks the adaptive notification management, where it fails to adjust alert type based on the context. This creates a potential of cognitive overload or conflicting input.
Hi, my name is Siap Tekai. I'm going to presenting about the architecture highlights of our GTSH system. So this system runs on Atlas middleware, a 6 layers architecture that connects physical sensors like smart floor and beds, all the way up to the application layer using OSGI plugs and play bundles, meaning new devices can be added without rebuilding the system. This follows the smart DEI framework, device, environments, and interactions. Most importantly, the interaction is implicit. When user walk across the floor or goes to sleep, the system responds automatically. The user never press a button. It means that this technology is truly disappear. Next, let us move on to the demo part of our improved prototype. So this is our privacy and claim dashboard. It's live and interactive. When the user approaches the smart mirror, it greets her by her name and presents a padlock icon as her entry point to privacy control. So there's also a message at below. Fall detection and emergency alert are always active and cannot be disabled. Next, let's move on to the second tab, which is My Data tabs. So in this tab, the user can see exactly which sensor are active, the smart floor tracking the location in the kitchen, the bed logging last night's sleep, and the front door cameras. And below that, the user can see who the data is shared with. For example, in this use case, it's shared with the caregiver, Jen, and so the doctor. And there's one more option that the user can share with the family groups. So they, the user can customize the the data who is going to be shared. So the user can also toggle. For example, he want to disable the data share to the caregiver, he can toggle off or toggle on. So next, we move on to the sensor tabs. So in this sensor tabs, the user can actually control which sensor to be enable and disable. So user have the choice to toggle any of these sensor on and off except for the flaw sensor and fall detection. As I mentioned before, flaw sensor and fall detection are safely critical issue and remain permanent active. Means the user cannot turn off these sensors and fall detections. Okay, to prevent the user from accidentally disable these critical functions. And finally, we move on to the alerts tabs, which will show all the upcoming reminders. For example, this is the medications reminder. So the reminder way is through the gentle light border on mirrors, and the next reminder will be visual exercise. It will be reminder via soft audio chimes. And user can also customize how the system are going to remind the user. For example, you can choose light borders, screen pop-up, using audios or all channels. So this actually solve our attentions and calmness weaknesses by letting the user control how the system are going to reach out to them. And user can also preview how the alert are going to be. For example, this is gentle alerts, this is the emergency alerts. So I think that's all for our demo parts. I'll pass to Chisen to explain about how this design choose map to our aquarium improvement.
Hi, my name is Tan Jason. I'm gonna explain on the proposed design improvements. So for our solution is to create a privacy and calm dashboard. So we will display on this 4 UI, example UI. So it will use a large text and a simple icon, so it will easy for elderly or senior to use. So it will mainly focus on 3 things. The first one is a data visibility, second is a customizable control, and the last one is a adaptive modality. So for the data visibility, resident can clearly see what exactly which sensor are on or off and who their data is being shared with at any given time. So the second is a customizable control. Residents can easily turn off a non-critical sensor like for example the path camera whenever they want. But it doesn't affect the safety features because the system is smart enough to keep the emergency features like fall detections permanently active to guarantee their safety. The last one is adaptive modality. Residents get to choose how the house communicate with them, so they can swap out the loud or sudden alarms to a gentle visual cue to keep their home peaceful. So in conclusions, I would say the Gator Tech Smart House is great for independent living, but its invisible design make a resident feel uneasy because too many privacy things leaked, right? So our dashboard fixing this by giving the control back to the user. It lower the stress and stop the home from feeling like a surveillance systems, all while keeping the critical emergency features running. Lastly, we also putting the resident in charge of their data, turn the smart house into a trust partner, not a hidden watcher. Thank you.